Now let's look at another example problem. So we're not introducing anything new in this example problem. It's really just to illustrate how to apply a sliding window. So this is a lead code problem, minimum window substring. So actually this problem is considered hard on lead code, even though it's really very standard sliding window technique. So here's the problem description. So we are given two strings, an S and a T. So T kind of stands for target. So we are trying to find the minimum window in S, which contains all the characters in T. So the definition of this problem is if a character appears in T multiple times, then the window should contain at least that number times of characters. So essentially, if you take all the characters in this window, and then it's possible to use these characters, a subset of them, and rearrange it and to get the string T. And if such windows do not exist, so which basically means that even the whole string S will not be able to reconstruct the string T, then return empty string. If there is, and the question asks us to find the minimum window. So the desired complexity is a big O n, where n is, if we think of length of input, it'll be the length of S plus length of T. So basically we want a linear time algorithm for doing this. So here's the example. Suppose S is this string and T is ABC. Then we want to find the window in S that include the 1A and 1B and 1C, or at least that, and we want the shortest one. So it turns out that for this particular instance, the shortest window, the smallest window, is the last four characters, B, A, and C, so length 4, and it covers the character we need. So I guess if it's AA, BC, if we need 2A, then probably it'll be from here to here, which will cover the 2A, and it has a B and C. So there's really no other way to cover 2A. So from the beginning to this second A. So so again, we will be maintaining a sliding window, and these have the monotonicity property that if one window works, then certainly any bigger window will work, and we want to find the minimum one. So what do we need to maintain for the window? So we need to know how many times each character occur in the window, and so then we can tell whether S is satisfied, so whether these characters are sufficient to make S. So we can use a map from character to integer, or more efficiently we'll simply use an array, because characters are the possible value for characters are small, so we'll they should be ASCII characters, so we'll go from it'll be a subset of from 0 to 127, so we can use an array. Again, I would like to encourage you to think in terms of array is also a map is also array. It's which one do we use really depends on the keys. If the key is a small integer, we use array. If the key are not small integers, either more complex object or bigger integer, we use a map. So and to enable checking whether a window include all the characters to make T, to make that check also constant time, we want to maintain an extra variable which counts how many characters in T have been satisfied. So this is similar to the call lineup problem we talked about earlier. So essentially, anytime we see a new character, we increment that counter. If this is the first time that counter go above the number of that characters in the string t, we will increment that. So now a new character has been satisfied. And when we shift the window, if we are about to shift the window so that the number of that occurrence, number of occurrence of that character is less than the number of occurrence of that character in t, then we don't shift, because we know doing so will make the window bad. So very similar to the call lineup problem. And encourage you to code yourself, because once you grasp the concept, writing the code, it's fairly straightforward. And if it takes you some time to actually get the logic right, then that's really the right practice for you to do.